Thank you and welcome to the first episode of CMA Dr. Jerry. In this episode, we're going to talk about ABG, specifically the pulse oximeter. So, the development of pulse oximeter, or the simpler oximeters, to measure the oxygen saturation has become very important in improving the monitoring of oxygen therapy. The sigmoid saturation curve, it's going to be covered for hemoglobin, it's going to be covered in the next series or next lecture. It defines the relationship between the saturation and the arterial pressure of oxygen. The oximeters, they work on the principle that desaturated hemoglobin and oxygenated hemoglobin absorb light of different wavelengths. So the current device uses two wavelengths and measures the absorption in the pulsatile element of the blood flow. Thus, it produces producing a measure of the oxygen saturation of arterial blood separate from the non-pulsatile venous blood. So when we put a typical simple oximeter is this. So when we put the oxygen, what we put it into, we put the probe applied to the finger or the earlobe. So the probe is applied to the finger or the earlobe, and the delay in the registration of the central changes in the saturation depends on the circulation time from the lungs to the monitoring site. So that device uses two wavelengths and measures the absorption in the pulsatile element of the blood flow, thus producing a measure of the oxygen saturation of arterial blood separate from the non-pulsatile venous blood. So you can see this, the light beeping inside. That's the wavelength we are referring to, the infrared light. So it measures the absorption in the pulsatile element of the blood flow. So it is slightly greater for the finger. It's greater for the finger, about 30 seconds. It's applied slightly to the finger, 30 seconds. Oximeters tend to be less accurate. Remember, take note. The oximeters tend to be less accurate with saturations below 75%. But for most clinical cases, changes above this range are more important. So in some clinical studies, it can affect accuracy of measurement. So this is a typical pulse oximeter. So there's a button on top of it. You press it, it's gonna turn on. You see, pulse oximeter. It has a SpO2 reading on top and the pulse on top. So put it into the finger, turn it on, and you'll see the reading. So it's reading. So my saturation is 96%, pulse rate is 83. So in this paper here, you can see the adult values. So this in this first column, we have the PaO2 or the arterial pressure of oxygen. So this column here is usually all these values here is important when you are doing an ABG. But on the other end, this saturation of oxygen, it's measured from the pulse oximeter. So I put the pulse oximeter on top of it so that you can remember. So when we say it's normal, that person must have a saturation of 97 or 95 and above. The person is diagnosed as having hypoxemia if the PaO2 or water pressure of oxygen within the ABG, measured in ABG, is less than 10.7, or in the saturation in the pulse oximeter, it's less than 95. If it is mild, then the saturation is between 90 to 94. If it is moderate, the saturation is between 75 to 89. If it is severe, then it's less than 75%. So next time when you are not attending to a patient, when you're reporting to someone, to your colleague, you can just mention normal, mild, moderate, or severe. So when you're saying patient is having a mild hypoxia, moderate hypoxia, or severe hypoxia, if it's mild hypoxia, they call it it's between 90 to 94. If it is severe, they call it that his oxygen saturation is less than 75. So less than 75, we give oxygen. Normal, mild, we can work around the clock to correct and improve the saturation. Our aim 95 to 100. Please don't forget to subscribe. Thank you.